All right, we're going to work through this problem, vowel remover. It says create a function shortcut to remove the lowercase vowels A, E, I, O, and U in a given string. And here we have a few examples. Pretty normal. We see that if the vowel is uppercase, it does not get removed, but all lowercase vowels do get removed. Here, of course, it says don't worry about uppercase vowels, and Y is not considered a vowel for this kata. So let's just jump right in. We'll go to train again. I have already done this problem at least sometime in the past. First thing I like to do is open the tests, and we'll go ahead and delete all of the tests except for one. Even this one, we're going to go ahead and reduce this down to our simplest case. Let's go ahead and make a message here. It handles strings of one character. You know what, let's just be extra proper here and handle an empty string. It handles an empty string. That's our true base case. There we go. And an empty string is an empty string. So we expect this to return an empty string. I see that it already by default is returning an empty string. Let's go ahead and click on test. And hey, we see that that works right out of the box. So let's open up our next it block here. You know what? I neglected to write a message here. Sample tests will not do. Let's say a function that removes all lowercase vowels from a string. There we go. That's better. And here we will say it handles a string with one character. My typing skills are not looking so sharp tonight. All right, let's start with the vowel A. That is the first letter in the alphabet. And an A should also return an empty string since it gets removed. Let's go ahead and run our tests again. And great, we see green again because we're just hard coding an empty string here. We'll go on to our next test. So I copy this test, and I want to find more tests that fall under this characterization here. So a string with one character, let's just move right to B. But a B should not return an empty string, it should return a B. Let's go ahead and run that. Okay, we see we've got our first failing test. Handles an empty string. This case is doing just fine, but handles a string with one character. For B, expected an empty string to equal B. So we'll start writing some code here. And let's say something like if string, I'm going to actually change this parameter name here to str. If string equals A, return an empty string, otherwise return string. So let's just think about this for a second. In our case with an empty string, this will not be true, and it will just return an empty string, so that looks good. For our next test, it will be equal to A and return an empty string. That also looks good. And for our last one, string is not going to be equal to A since it's a B, and it will return just B. So that also seems fine. Let's go ahead and run our tests. And great, we see that everything is passing. We'll move on to our next case. We'll move to like a C real quick. And we shouldn't have any trouble there. So we'll just go ahead and run that. Great. Now, of course, I could go D and every other consonant, but what I care more about here is the vowels. So let me throw in E, should return an empty string, and I should return an empty string, and O and U, these should all return empty strings. And let's go ahead and minimize that and test it. Okay, and we see that as soon as we get to E, we have a problem. So we could do something like if string equals A or string equals E, then return an empty string. So let's watch our test here and see if this one starts to pass, but we fail on another one. Yep, we see now we're failing on I. Okay, so I could just keep going and say, well, if string is equal to I, or if string is equal to O, or if string is equal to U. And let's say any vowel then will return an empty string, otherwise we'll return the string itself. Give that a try. Hey, what do you know? We're passing all of them now. Before we move on though, let's see if we can refactor this logic here to something a bit more concise. So I know that there's a string method called includes, and I could do something like vowels is equal to A, E, I, O, U. And then if I were to get rid of this and say something like vowels dot includes the string. So if this variable here, vowels, or this constant vowels, includes the string, then we want to return an empty string. Otherwise, return the string itself. Let's see if that still passes all of our tests. Hey, it does, and it's a bit easier to read, easier to maintain. So we will go with that for right now, and with that we'll move on to our next set of tests. Well, after a string with one character comes a string with 2 or 3 or 4 characters. We're going to label this handles a string with more than one character. And we'll start with AB, and we should get B. And I'm going to go ahead and comment out all of these tests. Let's go ahead and run that. And when we're following this test-driven development approach to a problem, we expect to fail lots of tests as we go. In fact, it's the failing tests that are sort of our boss telling us, hey, we've got a problem, you need to write some code to fix it. So we're getting back AB, and we expect it to only be B, which of course makes sense, since looking at this one, we'd say, well, we would remove the A and leave B. So we need to figure that out here. Once we move to these cases with more than one character, we need to loop over the string and look at each character in turn. So let's wrap this logic here in a loop and say something like, for every character of the string, and then we say, if character is vowel, do nothing. Another way we say do nothing inside of a loop is continue. And else, what do we do here? Save the character somewhere to return it later. Something like that. That's hardly pseudocode, but that's the idea that we want. So let's bring this up here. And we say, this is the logic for if a character is a vowel. But we don't want to return an empty string anymore because we have more characters to look at. So we might just say continue. Continue says don't go any further in this loop. Go right back to the top of the loop and go to the next character. So that covers this one right here. Do nothing, continue. In fact, I can show it more properly by doing something like this. We're going to put our pseudocode right here. Okay, and now we're ready to go with our else. To forgive my very poor typing, else, and this guy will go in here. Else, save the character somewhere to return it later. Well, let's find somewhere to save it. For that, we're going to need a variable. Let's come up here and we'll say let string with lowercase vowels removed. String with no lowercase vowels. That seems a bit simpler. Let's set that to an empty string. And then here, let's use that as where we save our characters that are not lowercase vowels. So string with no lowercase vowels plus equals character. And we know this character is not a vowel because if it is, it would have fallen into this first statement here. Now it's no longer enough to just return string. We want to return this string with no lowercase vowels. If you are looking at that variable like, wow, that is a really long name, I want to encourage you to work towards naming your vowels or your variables very descriptively. And there is absolutely nothing wrong with a variable that has a few more words in it that can help future us or a coworker, colleague, interviewer better understand and read our code. All right, let's give that a run and see if we have any issues there. Okay, we still have a problem here. We expected AB to equal B. So, what is going wrong here? Oh, I see the problem. The problem is I've created this new variable char for every character, but here I'm still looking at str. So let's fix that. Let's put in char right here and go again. Hey, now we're passing everything. That's great. Let's move on to our next test. I'm just going to comment this in, and here we say B, C, D. Sure, this one has no vowels, and it should be exactly the same. Let's run that. Great. Let's go to our next one. We'll do A, B, C, D, E, and here we expect to get B, C, D. Similar to our last one, but the A and the E both will be removed. Run that. Very good. All right, I always like to work on some of the examples that a problem gives us. So let's start plugging in some of those. We have hello, and we get HLL. Next, we have Codewars, and we get CDWRS. Next, we have goodbye, and we get GDBY. And finally, we have hello, all uppercase, and it is exactly the same. So we've added quite a few tests. Let's go ahead and run that. Great. Looks like we're passing all of those. I think we've pretty well covered. We started with our base case, an empty string. We handled our next simplest case, which is a string of one character. And then we moved up, and you can kind of see it almost looks like stairs here as we go from 2 to 3 to 4 to 5 up to 7 or 8 or so, and then sort of a different case of capital letters. And we are good. Let's see if we can improve our code at all. It seems a bit unwieldy here. One thing is, if I ever see an if statement that has nothing except for continue inside of it, it's a really good idea we can actually get rid of it. So what we can do here is say, all right, if something is a vowel, we don't really want to do anything. Let's change this to say if the character is not a vowel. So let's take this same statement with a bang operator in front of it, showing that we want the opposite. This says if a character is not included in vowels, then we're going to go ahead and add it to this string with no lowercase vowels. With that, now we can just chop all of this as well as the pseudocode. And there we've got our loop here going over every character. If the character is not a vowel, add it to our variable and then save this down here. Run our tests again. I'll just, almost every time I make some kind of change, I'm running my tests. I don't want to get too far ahead of myself. This pseudocode can go, if we can even call that pseudocode, that note that I made. Great, looking good. All right, there's one more thing I think we can improve here in terms of our runtime, and that is we've got includes nested inside of our loop. This isn't terribly inefficient, but every time we run includes, it can run up to 5 times as it looks at each one of these vowels. So let's use a data type called a set for vowels, and we'll increase our efficiency here just a little bit. So we'll still call it vowels. We're going to create a new set. Don't worry too much if you don't, if you've not heard about sets before, it's something you're not familiar with. I really wouldn't stress it. This is a marginal increase in efficiency, and you can always learn about this later. So we're going to create an array with all of our vowels, A, E, I, O, and U. What that's going to do, it's going to create a set. A set holds only unique values. We have 5 unique values here. And then instead of saying dot includes works on strings, but now we have a set. Sets have a method called has. It does pretty much the same thing. It's saying, does this thing called this vowel set, does it have this character? If it does not, let's go ahead and add it here. So let's run our test one more time. That looks very good. And with that, we are ready to submit our problem. Our goal is always to pass green the first time we click attempt. We can fail our test as many times as we want or need, but when I click attempt, I always want to have green. I think we're good to go here. Let's go ahead and click that. Beautiful. We see everything passes, and we'll go ahead and submit that. All right, and we move right over to other people's solutions. There's a nice solution here with replace using a regular expression. Not an approach I took this time, but a perfectly good approach to check out. And here's someone splitting this into an array of characters and then filtering them, checking. This is index of is very similar to includes. It's a bit of an older method in JavaScript, but does largely the same thing. Same thing here. You can see they have this string of vowels and then they do includes, similar to what we had done in the first place. So great, let's go ahead and leave it there. That's our solution for today. Thanks so much.